This is House Planning Help, episode 44. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're looking to build a new home or retrofit an existing property. I'm exploring what houses we should be building in the 21st century. My personal goal is to create an energy-efficient home before I turn 40 in August 2016. Coming up in this session, Mark Siddall from Leap is my guest, and we're going to be looking at how to avoid the risks of poor ventilation. So I realised I haven't done this for a while, and just a big thank you to you for downloading this episode, for all the encouragement, the emails, the support. And I thought we'd do this in reverse today, some of the iTunes reviews as well. Let's read a couple of them. This is from SG79F. They don't allow you to put your real name on iTunes. I have no idea why. I'm not an eco-build geek or self-build dreamer, but I stumbled upon this and find lots of topics really interesting. It's presented in a really relaxed, friendly way and well worth a listen. Thank you, SG79F. There's also one from FireNat who says, I've only just discovered this podcast in the last week or so and have just completed listening to all the episodes. Whoa, that must have taken some doing. It's excellently produced, and I have found that Ben's voice is clear enough for me to listen at ×2 speed. I imagine to get it all done in that time, you'd need to do that. I have also just purchased the book Why Most People Don't Build Energy Efficient Homes from the Snippet app. The general state of house building in the UK is truly dire. I have evidence to prove it, gathered by thermal image surveys of new houses. Something must be done if we're to reach our carbon reduction targets in time to prevent catastrophic climate change. We shouldn't have to think about retrofitting new build properties. Definitely got a big point there. And this should be essential listening for all architects, builders and contractors to increase their knowledge. Well, we're not exactly aimed at them, but they're always welcome to come along. Really appreciate those iTunes reviews. And if you can add one, you might have heard in the last couple of episodes that I set myself this, to be honest, ambitious target, an iTunes challenge to reach 100 reviews by episode 50. Currently we're on episode 44 and I'm only on 29 reviews. Yeah, as I say, so maybe I am being a little bit ambitious. Let's do the maths here. So that would mean I would have to get 12 reviews averaging in between each episode. Not sure how likely that is, but if you can help, if you're someone who can write a review on iTunes, it doesn't even have to be very long, just a couple of sentences, then that will help other people find our podcast too. Brilliant. Thank you very much for that. Mark Siddall trained as an architectural technologist before going on to be an architect, and he's really interested in Passive House too, loves all the detailing. And what I like about Mark is how he gets involved in the research side as well. He runs LEAP, which is an acronym for Low Energy Architectural Practice. And in this session, we're going to focus on the causes of poor ventilation and how to avoid them. But I started by asking Mark why we might be worried about poor ventilation.
Well, poor ventilation can lead to poor well-being. If it all went very wrong, then you can have mould and fungus growing in the on the surfaces, in the carpets, etc., and that can cause respiratory problems. If you've got very low humidities, that can also cause your immune system to become depleted. So, yeah, at the end of the day, there's a range of impacts that can lead to increased incidence of asthma and the likes as well. So we've got to really get the ventilation side of things sorted out. If humidity gets too high, then dust mites can populate a home quite quickly, and that can increase the incidence of asthma.
Looking at a natural ventilation situation, do we actually control it well? In that situation, would we always, as the occupants of houses, do a good job?
I think that there's a reasonable amount of evidence to suggest that we just get on with our lives. We only react when we kind of perceive a problem to exist. And in that respect, if we're in an old home that's quite leaky and not particularly airtight, it's sufficiently leaky for it not to cause any particular issues. But as you move to increasingly airtight buildings, then actually the control strategy becomes more and more important. So therefore, designing either a mechanical or a natural ventilation system requires greater and greater attention. One of the issues that can then arise with natural ventilated strategies is actually designing it appropriately to deal with the very different environmental conditions. And from my perspective, this also goes back to issues of comfort, because often what you find is that people will close things like trickle vents because they don't like the cold draft. And in doing so, they compromise their indoor air quality.
What do we have to have in a house for ventilation? What are the regulations? You'll probably have to say the UK regulations, but on the whole, as houses are built.
Well, in the UK, there are 4 different strategies that are recognised within the building regulations. There are some other strategies which are finding kind of recognition within the building regulations in the future, but they're not kind of an identified system at the moment. So the 4 primary systems, system 1 is basically windows with trickle vents and mechanical extract ventilation. You have the same again, but with passive stack ventilation instead of mechanical fans. Then you have mechanical extract ventilation and mechanical ventilation with heat recovery.
And the passive stack is not used that often, is it? According to, you have different types that are used more and more, and I suppose we're heading towards the latter.
Yeah, passive stack is less frequently used. The mechanical extract ventilation with trickle vents is by far the most commonplace ventilation strategy that's been used in the UK so far. But increasingly, as lower energy buildings are coming into play, then mechanical extract ventilation and mechanical ventilation with heat recovery are becoming more predominant. And there does seem to be a jump straight to mechanical ventilation with heat recovery rather than dwelling on the mechanical extract ventilation strategies.
Having a quick think about going back to that situation of, I'm the occupant, I'm going to switch off the ventilation. I know you have a few stories on this. So why? Why, if you were in a more airtight house, would you ever think of switching off the ventilation system?
Well, it's a good question. There's a range of different reasons that can occur to people. Some people perceive that a mechanical ventilation strategy is more costly. They perceive that the electricity that's used is actually incurring them higher fuel bills, which need not necessarily be the case if it's a well-designed system with some low-energy fans. I think that can influence people that are certainly more aware of their finances. People that are more environmentally aware might think that by switching off the ventilation system, they are reducing their carbon emissions, so that they might perceive that as being a good thing.
But these are myths.
Oh, yes. Yeah. These are perceptions. These are not realities. And then there's also the issue whereby if there's noise from the ventilation system, then people they want to get a decent night's sleep, so they'll end up switching off or switching down the ventilation system in that case. And that can obviously have an impact upon the indoor air quality as well.
The topic of noise, should there ever be any noise from ventilation, or does it depend on certain factors?
I think that on a purist environmental basis, there will always be some noise in some form or another, whether it's a natural ventilation strategy through trickle ventilators. They're not acoustically sound, should we say, in the purest sense. Along to mechanical ventilation systems, they've got fans and the likes. Now, you can actually get down to levels which are, should we say, deemed appropriate. The World Health Organization defines an appropriate noise standard as being 35 dBA. Decibels. Then for mechanical ventilation systems, there's a range of different acoustic targets that you might try and conform to, depending on whether you're referring to UK building regulations and its recommendations, or whether you're referring to good practice.
We as clients will come into this just thinking, we want our ventilation system. So how do we know that we're going to get something that is not going to make much noise? Is it a case of just looking at different sheets and it will say these dB, or what do we need to be aware of?
Well, basically, with a mechanical system, the key is making sure that, first of all, the designer of the mechanical ventilation system understands the acoustic requirements. And therefore, they can then size attenuators. So effectively like a car, you have an attenuator on your car exhaust. Same kind of concept. You can have attenuators situated in appropriate locations within the house to prevent breakout noise from the ventilation system into your rooms, and also to help reduce the risk of noise transfer between rooms, telephonic noise transfer.
So that's the noise that would just be funneled?
Yes, it's the noise that would be channeling itself down the ductwork to the respective rooms from the ventilation system itself. You might also have other noise, of course, from the outside environment that could also be seeking to get into the home in a sense. You might normally control that through closing windows and the likes.
When we have these systems, I know that they always say that you want to have short duct rungs, but what other parts of the design should you go? I think what I'm getting at here is, how do I know that the professional that I'm hiring is going to do a good job and to take into account all these things that will make a difference?
At the moment, I think that's a really challenging one, if I'm honest. My approach is there are certain people that I have worked with before. I know they do a good job, and I seek to use them time and time again because I know that they can deliver. If I was to go out into industry in general, I'd be a lot more hesitant. I'd probably have to do a lot more work in terms of policing these other people I'm not familiar with, and that leads to more time and cost and things like that. So it swings and roundabouts. You're trying to deliver, in terms of the overall design process. I think I and others are seeking to deliver a good quality product at an affordable price, and that means working with supply chains that you've established.
Sometimes it's easier to picture the opposite situation. What do we not want to end up with?
Well, what we don't want to end up with is a ventilation system that's been kind of undersized, so therefore it's not ventilating appropriately. Or alternatively, you don't want a system that's been oversized so that it's ventilating too much, because that can lead to dry air in the winter. You don't want a noisy system, so therefore you've got to make sure the design's been right in the first place. You don't want a situation whereby you've got dirty ductwork and debris, because that can cause dry throats and sore eyes. So you've got to think about that. You've got to make sure that if you're using ventilation heat recovery systems, then there's also condensate drains in the right places, which is so therefore you've got to think about the positioning of the MVHR units, and it goes on. It requires quite in-depth knowledge and time and expertise to kind of really get on top of that.
As someone who has experienced a few MVHR systems, every so often you're perhaps under the impression that you might be getting dry air. Is that the case?
In a manner of speaking, yes, but in the ultimate reality, is it? I suppose for me the question is it a cause of the MVHR system itself, or is it some other cause? And when you dig down into the details of it, you start to get embroiled in some finer levels of physics, which I'll try and avoid right now. But needless to say that if it's a cold weather outside, say 0 degrees outside, then the air can only hold so much moisture. When you bring that moisture inside the building and raise its temperature, the relative humidity of that air drops, in a relative sense. And it's that dry air that is then created that we might then perceive through dry noses, dry eyes and the likes. Now, it's important to recognise that this is a phenomenon because it's cold outside and warmer inside, and you're supplying a certain amount of air that's diluting the level of moisture within the home. That's irrespective of whether you're talking about a mechanical system or a natural system, assuming that they're both supplying the right amount of, or the same amount of fresh air. What you tend to find, though, is that where there are reports of drier air, it tends to be in buildings that have got more mechanical ventilation systems. And that is because, I would argue, the systems are actually constantly providing that ventilation, whereas natural ventilation in itself is inconsistent. So sometimes it's over-ventilating, other times, more worryingly, it's under-ventilating. So you end up with this hodgepodge of indoor air qualities that come with natural ventilation. A well-designed mechanical system will have a lower air change rate in order to ensure adequate indoor air quality as compared to that of natural ventilation, because it's more constant than that variable scenario. So you get something called ventilation efficiency. And then in doing so, you've got a lower air change rate, so your humidity levels can be at a higher level, whilst ensuring that you've got the best possible indoor air quality for all removing of volatile organic compounds and other aspects of off-gassing. You can also then, if it's particularly cold outside, you've got your fan settings, and you can drop down for a limited period of time down to a lower setting just to allow the indoor humidities to kind of crest through those particularly dry periods where you might be finding there's a little bit of discomfort. And people's perception of humidity depends on their age, on their gender. So there's a whole host of different things that can start to influence perceptions of humidity and what is comfortable to one person and another. So it's very much individual, and it's something that building regulations doesn't actually accommodate for at the moment. The mechanical systems have got to ventilate at the same kind of theoretical level as natural ventilation systems, and that is why you might be getting issues that can arise from time to time in terms of, in the UK, complaints about dry air. But I must say, at Racecourse, the post-occupancy surveys that we didn't suggest that there were any moisture, dry air issues there, though there were people at Lancaster reporting drier air. having spoken to occupants there, they're suggesting that yes, it's drier air than they might have been used to, but it doesn't mean that it's causing discomfort necessarily. So it's how some of these questionnaires are structured. Is it dry, or is it kind of moist or humid? There isn't, is it too dry or is it too moist? And that's where it can create some sort of misunderstandings.
Maybe we could alter our path a little bit here, because I remember that when I came up to the racecourse bungalows and did some video work with you guys, that you were carrying out some surveys and taking in some data. So what were you actually looking at there?
Well, what we were doing there was we were actually measuring, I was working with Jack Harvey Clark from Apex Acoustics, and he was measuring the noise from within the household. So we were trying to identify whether there were noise issues or potential noise issues from the ventilation system that was installed in those properties. And then that in turn has led on to a paper that we've now written that was tabled at the Institute for Acoustics. In that particular instance at Racecourse, we found that the alarm clock and the kitchen clock and the fridge were noisier than the ventilation system, which was a good thing. That meant that we'd done our job right at the design stage, the contractor had completed the work appropriately, the system had been commissioned, and this is a really vital one that I didn't mention before. You've got to make sure that the ventilation systems are commissioned appropriately, so therefore you make sure that the flow rates are correct, and that means that you're less likely to be getting too much noise from systems, and also that you'll end up with appropriate indoor air quality.
When we purge air, let's say there are lots of people in there, or there's some reason that you overheating, you get uncomfortable, will that naturally create more noise?
There's different ways to look at things, I suppose, and when you use the term purge, building regulations defines purge ventilation in a specific way, which is to open windows. So therefore, if you've got humidity from having boiled kettles or making a stew or having had a bath and you open a bathroom window, that's purge ventilation when you're opening the window to remove that humidity. There might be other times where the house hasn't got too humid. You might push a boost button on the ventilation system, and that will help extract any kind of excess moisture in a more controlled fashion. Yeah, I think, those are the two basic strategies. You've got the boost button and you've also got the window opening.
If you're in a passive house, I'm always under the impression that you don't really have to do very much. This could be the wrong idea, but how much will you be controlling that ventilation?
Well, you've got perfect control over the ventilation. It's your choice how you run and operate the building. There are a range of different fan speeds that you might use with different mechanical ventilation strategies. So therefore, you can control the rate at which the building is ventilated. And of course, you can always open the windows, no matter what time of year it is, to adjust the indoor climate or to change the indoor air quality in some form or another if you wanted to do so. So you've got ultimate control at the end of the day. What I've kind of experienced, say from Racecourse, was that in the summer, because these were bungalows, people were sleeping on the ground floor, and they were living on the ground floor. And in that particular environment, there was greater concern about security than we'd necessarily envisaged. And this wasn't what we designed everything appropriately from our point of view as designers, thinking about the addressing security issues. But what came up in reality was that tenants perceived a greater risk, and in doing so were less likely to open the windows. Even with tilt and turn windows, which if you tilt a window inwards, it's arguably more secure. Somebody can't get their hands through the window, can't dive through the window, those kind of things. But people were not leaving those windows open at night, and therefore there is a higher reported incidence of overheating, or the building generally getting warm, than we'd have necessarily expected. And that's because of, should we say, inappropriate ventilation strategies, in a manner of speaking, but for understandable reasons. So what the lesson learned from that is that we need to think carefully about those associations between security and ventilation, or between noise and ventilation. There's other instances where people won't open windows because of the noise outside, and therefore the indoor air temperatures end up rising to levels which are causing discomfort, until they finally get to that crisis point whereby, well, it's so hot inside now, I'd rather put up with the awful noise outside. It's about these thresholds of discomfort and how people react to them. And regulations they often compartmentalise thinking. And we aren't, people don't compartmentalise that thinking in their own life. So therefore, it's those interfaces which are the most complicated and interesting things and most under-researched elements, especially with ventilation.
I know we are probably unlikely to do this, but if we switched off the ventilation system in a passive house, I've always wondered this, what would happen to you as a person? What would you say the likely behaviour would be? Could you end up suffocating inside because it's an airtight house?
No. There is that a myth. And I mean, it's a myth that I also explored myself because I was concerned about how airtight is too airtight. Is it like putting a plastic bag over your head? And the answer is no. Basically, the background ventilation through the level of airtightness is such that you won't suffocate. You might react because you'll start to feel it's too humid and uncomfortable, and in doing so, you'll end up opening windows. I was recently in a Code 6 home that had ventilation heat recovery, but the system was, it was switched off when I went into the building, and I wondered why. But what the occupants had done is open the windows to help ventilate the property. When I switched on the ventilation heat recovery system, basically the ground almost shook. It was the MVHR system was located at first floor, and it was thunderous, really. And I couldn't believe that a system had been built and commissioned and performed in such a way. The tenant, understandably, had just switched off the noise, the cause of the noise, switched off the MVHR system. And once that noise has gone away, they don't need to tell anybody about it because they've addressed their problem. So, they haven't necessarily fed back to the owner of the property that there is a specific issue with the ventilation system being too noisy. The tenants just said, it's too noisy, I can stop that through turning the system off, and that's what they've done.
Did you get an opportunity in that situation to find out how had they coped during that time? Had they felt this isn't as good as it had been and perhaps wanted to get it fixed?
No, they'd just gone back to what they were used to doing, which was you just open the windows, don't you? So they just ended up having the windows open.
But their experience can't have been as good.
Their experience, they would have been experiencing more discomfort than may otherwise have been the case. But if the system was so noisy when they moved in, they just switched it off and went back to their old way of living. They don't know any different in a sense, and it's wrong to think that they've done something wrong.
Let's move on to Siddall Farm, which is a project that you've been working on recently. It'd be great to include a couple of pictures in the show notes, but maybe you could tell us about that, and then also, because we've been talking on this topic of ventilation, how you went about designing that system in a good way.
Mm-hmm. Yeah, well, Siddall Farm was a project that began a few years ago, and I was approached by Trevor and Judith because of their interest in Passive House. They live in a very remote rural location, and were interested in trying to improve the quality of their life insofar as they were, at one point in time, a winter a couple of years ago, they reported to me that it was warmer inside their fridge than it was inside the house that they were living in. We were trying to fix problems like that and give them a good, pleasant environment in which they could live. They also wanted to design a home that was big enough to cope with family visitors in the future, over time, and also so that when the farm was sold on in the future, then it would be a good family residence for another farmer. So we went through the design, a lot of the detail developed, 68 construction details to explain to a building contractor exactly what they needed to do, because I was very conscious of the fact that there were no builders in the area that were experienced building passive house buildings of that particular type, capable of dealing with a smaller one-off home. I've worked on larger projects like Racecourse where we've dealt with larger contractors, but this was a different kettle of fish. So there was a kind of very high degree of attention given to making sure that there was a smooth ride for the contractor so that they could price things appropriately and they could understand whatever perceived risks there may be, and they could work it out in a fair way that was amicable to the client and to themselves. So in that process, thinking about the design of the ventilation system, I was working with Alan Clark, the services engineer, because there was also the client had the design and a requirement for some solar thermal panels on the roof, and that goes out beyond my expertise. So Alan was on board, so he did the design for the heating system and also for the ventilation system at some initial stages, and developed some specifications for that. And then we worked that through it in more detail with Green Building Store, who supplied the Powell ventilation heat recovery unit. We used rigid ductwork because that ensures that we don't end up with kinks and bends in the ductwork, which can have negative impacts upon, well, we need more fan power to get the air to the right places if there's kinks, and that can then lead to more noise, for instance, or more electrical energy use than's desirable, a whole host of different issues. And also Green Building Store then designed the attenuators that I was mentioning earlier to get noise levels down to an appropriate point.
Clearly, there's a lot of piping or ducting that you're going to have on a project. So is that why you're trying to keep it down in size?
Well, you're trying to keep the lengths of ductwork down to a minimum, basically because there's more material and more labour and more cost. So it's just smart design to be conscious of those kinds of factors. In terms of yes, in doing so, you reduce the amount of embodied energy that might be associated with such systems. So that
is it very small amount, though? I mean, I don't know.
There are different studies that have been done, and at the end of the day, where you get to is it's the energy in use of the property, which far, far outweighs any embodied energy associated with the construction as a whole. So the first thing you do is you reduce the energy in use for a building of whatever type, and then the next notch down would be to focus upon embodied energy. So there's an order of logic, shall we say. It does depend upon the life cycle of the property, of course, but residential properties we tend to think of as lasting quite extended periods of time.
Well, as we come to the end of this interview, I don't know whether there's any big gaping hole that I've left here. It's a technical subject, and I know you're a technical guy and could go into lots more detail, but just as an overview for us.
I think we've covered a lot of the bases already. The one thing that we haven't really touched on too much is cleanliness. And one of the things that's come out, I've been doing quite a bit of research into this area as well, and I've come across some great finish standards that help classify how clean is clean, because the Passive House standard says your ductwork should be clean, but how clean is clean? What level of cleanliness is it reasonable to expect from a building contractor? Should it be laboratory clean, or is a little bit of dirt okay, or is the crisp packet and a bit of mortar okay? So, by and large, you need to ensure that the ductwork is clean when it's designed and constructed. And by far the most dirt will get into the construction during the construction process. So you need to pay some very careful attention to that. If you don't, then it can result in, as I mentioned earlier on, drier eyes, sore throats, other things that are associated with sick building syndrome in a manner of speaking. And that's just through poor attention to the construction processes. Once the ductwork's installed, do we need to worry about cleaning the ductwork out because of any dirt and debris that could accumulate within the system? Well, that was a concern I had, so I emailed Wolfgang Feist and said, Professor Feist, please could you help me? I'm curious to know what's going on inside of your ventilation and heat recovery system. And he said, well, okay, I've had a look inside about 10 years later, and it was as clean then as it was the day when we finished. So there's not really an issue in terms of dirt accumulation, provided you're keeping the filters changed on the systems appropriately, and that's something we haven't really mentioned. So if you keep the filters changed regularly, then you're not bringing in external dirt into the building or in through the ductwork system, and you're preventing any dirt that's on the way out of the building from accumulating within the heat exchanger itself. It's very important to make sure that those filters are changed regularly, and it's very important to make sure that the filters are actually in place. Because again, going back to that Code 6 project, the filters were missing. So therefore, you had the issue whereby external dirt would be brought directly into the heat exchanger, could over time compromise the performance of the heat exchanger in some form or another, and effectively you weren't actually filtering out the particulates that were otherwise finding their way into the home. Now, does that mean it was worse than a naturally ventilated scenario? Perhaps not in the first instance, because it's external air coming inside, and therefore the particulate levels will be the same. What you're not getting is that cleaner level of air. The issue would arise if something was going on within the heat exchanger, where there is condensation, there was the potential risk of mould growth and cross-contamination, if the system hadn't been designed and constructed appropriately. Passive House requires that you should, it sets limits upon the amount of cross-contamination that can and should occur, and that's part of the design process.
Well, some great information today. I'd like to sum up, and maybe you could say if this is pretty spot on, but the design of this and the people who put it all together, a lot of it goes back to that, doesn't it? And really, as users, there's not too much that we need to get involved with, but we shouldn't be switching off the systems.
No. Well, an appropriately designed system is easy to maintain. I had one remark. I was doing a tour around Siddall Farm at the Passive House Open days, and one person remarked upon the fact that MVHR is so much more simple than I realised it was. Because all they've got to do is change some filters, and if they want to, they can adjust the flow rates on the fan settings, and that's it. As an occupant, you shouldn't have to do any more. Anything else is down to the design and the construction, and ensuring that all of that work is done appropriately. So what you really need then is making sure that people have got the right knowledge, the right experience, and the right ability to be able to deliver these systems in practice.
Mark, thank you very much.
Thank you.
And you can find today's show notes online at houseplanninghelp.com/44. We've got some pictures of Siddall Farm in there, also some of the ventilation systems and the detailing that Mark was talking about. And if you've got any questions or comments, we might see if we can bring back Mark to answer those. So leave them at the bottom of the show notes. Once again, houseplanninghelp.com/44. So a couple of notices. One of them, I've actually been a guest on a few podcasts, so I thought I would tell you about this in case you fancy going to have a listen. You probably know about Matthew Cutler-Welsh and the Homestyle Green podcast, which I really enjoy, and I'm a regular listener myself. But I got to go and be a guest back on there, talking to Matthew about EcoBuild that's happened recently in the UK. That was my third EcoBuild that I went to. But the other aspect being the research that I've been doing here at House Planning Help, and just some of the key things that I feel I've learned over that initial year, and it's coming up to about a year and a half now. Then there was the Construction Marketing podcast. If you're into content marketing, I had a geek out on that with Pritesh Patel. So that's a great one to check out. And this, away from my remit perhaps, but I really enjoyed this. Shay Harms is someone that I met out at NMX, the New Media Conference, and she does a weight loss podcast. Now, I'm already slim, so I have no stories about weight loss, but she was really interested to contrast the food and the portion size that we have in the UK compared to the States, which I was very happy to do because I found actually on my trip to the States that I didn't like mealtime anymore. I just felt, oh my goodness, I'm going to get a huge portion of food and then I'm not going to be able to eat it and then I'm going to feel bad for the wastage. So it was a really interesting discussion, and I'll link to that in the show notes too. So 3 podcasts you can check out: Homestyle Green, the Construction Marketing Podcast, and Slender Safari. And finally, if you're on Twitter, I'd love it if you could help spread the message about this podcast. We've made it really easy to by crafting a tweet. So all you have to do is head to houseplanninghelp.com/share, as in sharing something, SHARE, and then you should see it automatically happens and you think, wow, this is magic. Next time, you can hear the debate from our Google Plus Hangout. It was a good session that we had with Matthew Cutler-Welsh, Roger Hunt and Lloyd Alter, the topic being, why aren't more people retrofitting their homes? So I hope you can join me for that one. Until then, take care.